Earlier on, I mentioned probability functions and cumulative functions. Let's look at this in more detail. Essentially, for each distribution, you have two functions available to you to solve the problem. If you want a value, you use the probability function. But if you want something like p with x less than between a range of values or above certain values, you can use the cumulative distribution function. This gets us to the use of tables. Let's look at the binomial distribution with n equals 10 and p equals to 45%. If I asked you, what is the probability of x being less or equal than 4, you need to sum all values from 0 to 4, or just use the cumulative function that already has that computed result. Same thing if you need x less than 4, x greater than 4, or greater n equal than 4, same thing. This is where the CDF kicks in, and you can use it to solve these types of questions. With the normal and any of the discrete ones, in order to get the right values, there are some rules to remember. The last point to remember is that in order to use the tables when using the normal distribution, we need to always normalize and get the x values in standardized form. So if you have a problem where x follows a normal distribution with a mean of 750, and the question is, what is the probability of x being greater than, let's say, 700, use the same properties that we have been talking about by first normalizing it and now getting z instead of x, with a mean 0 and 1 standard deviation. Then we use the properties to deal with the greater than sign or the negative number. From the z table, we will get the answer.